You will find all of these, chapter 12, very top of the Google Classroom. Hey. All right, so we're going to try a confidence interval question. So there we are given some data from somebody's AP project. We have a printout, which is awesome, but the reason the data is here is we needed to check the conditions. So just a reminder for how this works, you're going to go to Stat. I'm going to go to Edit. You're going to clear the list you have, so you put your cursor on the name of the list, list 2, you can hit Clear, Enter. List 1, cursor up, clear, enter. So I'm going to put, this is a funky one, you have each X value gets 3 data points. That'll allow for that equal summation around each point situation to happen. So we're putting these in. I know it's very riveting. Also, I want to say I didn't teach this one last year. It was explicitly not on the test last year, so let's see how it goes. Okay, so here's our data. We're going to go Stat, Calculate, Linear Regression, option 4. This one and this 2 is what I want. Oh, don't want that. Try clearing that. And then do you want to store your regression equation so you don't have to type it? If you do want to, you go to Variables, Y variables, function, Y1. We store this in Y1. So here's my equation. Let's see if I did a good job. Uh-oh. Possible typo. Gonna check. 168, 180, 192, 192, 204, 204. Another 204, 210, 210, 222, 228, 22, 234. Okay, try again. Stat, calculate linear regression, please. Bars, y bars, function, yes. Ha, better. Okay. All right, so what are we estimating? We are estimating beta, the true slope of the true least square regression line that is going to connect of sugar versus flower freshness. That's what we're estimating. We have a sample of 12 points here. So for confidence interval, the state step is just this. What is it you're about to estimate? What is this whole procedure about? All right, here comes the fun part. Plan. We are doing A, options on the name. If you go to the calculator to tests, go way down at the bottom, linear regression T interval. Linear regression T interval. We have 5 conditions, minor. A little bit weird, a little bit out of order. This is our random sample. Got home, prepared 12 identical vases, same amount of water. They put a tablespoon of sugar in 3 vases, 2, etc. After the vases were prepared, students are randomly assigned. Ooh, experiment. So random assignment, don't write SRS. Is given. All right. Independence is your 10% condition, so we're going to assume that at least 12 flowers. We got 12 flowers, so at least 120 carnations exist. I think that seems safe. Is the relationship linear? Step plot. I'm going to turn on something. I'm going to make a scatter plot. It's going to be this one and this 2. I can zoom stat, zoom 9. Really. So this is my graph. Is this pattern linear? Yeah, ish. A better support for linear would be the residual plot. So since we ran the line in the calculator, we have stored the slope the y-intercept, the r squared, and all of the residuals. This is great. We're going to graph the residuals. So all I need to do is go here. I'm going to edit what I've got, and what I'm going to be doing is my original sugar level, and then instead of freshness, it's going to be the residual of freshness. So it's residual of freshness. So second stat, to go to list. In the alphabetical list here, way at the bottom in the R section, residuals. Please graph the residuals of the y's. Excellent. Zoom. 9. These are my residuals. So is this evenly scattered? That's the question, right? Is it a fan? Well, it's a little wide here. It's narrow, but these are also narrow, and they're not getting narrower. This is a really interesting one. It's a bit challenging. So linear, we're going to say scatter plot is about approximately linear, and then for our evidence, we're also going to supply the residual plot right here. Now I'm going to sketch what I see on my calculator, and then I just want to mention that you want to make sure that this sketch matches this in both number and variable. So you want to trace it. This is a negative 13. So maybe on here I put a negative 10. If there's a, so if you want to run around, if you want to jump around the points, you have to hit the right arrow. So then my maximum up here is a 10. So it goes from 10 to 10. So we're going to put the points on there. So we got one here, one really close to here, one up there. I'm just going to sketch what I see. By the way, there's supposed to be 3 points here, but 2 are the same. There's supposed to be 3 points here, but 2 are the same. This does happen sometimes. Okay. So this is a 3. Negative 10, negative 10. This is sugar. This is the residual of freshness. Now this is what I'm graphing. This is in context and not just numerically. That's what I want. So is this curving? Is it fanning? No clear fan. I'm a little suspicious, but okay, so that's going to help me with this one. It's helping support that it's linear when you look at the scatter plot. And then lastly, are these equally, is there no fan? And so equal SD for each x. So we said no fan in the residual plot. You can use that twice. And then lastly, this is the funky one, normal distribution of residuals. What I want to do is look at the residuals, see what shape they make. So it could be a dot plot of the residuals. Since this is all in my calculator anyway, what I'm going to do is graph just the residuals. So I'm going to change my type of graph to try histogram or box plot. It's a little bit of a weird call here. Let's try the box plot. So I actually literally want to graph my residual. Let's see if this will allow me to do that. Boom, 9. Is that symmetrical-ish? It's a really small data set. That median's in the middle. Sketch it. Yeah, the data set is too small to really have a good feel. And then I'm going to trace these. Again, so this is negative 13 to 10. So that one, it's not terrible. There's no outliers. There's no ridiculous skew, but that box is a little funky. Right. So cool, we have met our conditions. All right, now we're doing a confidence interval. Slope we actually got, plus or minus the critical value for this sample size and this degree of freedom times the standard error of the slope. So we are estimating beta by doing that. So our estimated beta is 15.2 plus or minus. So degree of freedom is n minus 2. So 12 flowers minus 2, which is 10. And then we are doing a 99% confidence interval. So to get our T star, we're combining that degree of freedom and a 99%. We'll see what it gives us. So 99% confident, degree of freedom 10. 3.169. That's how many standard deviations I need to go out from the middle to capture 99% of all potential data. And lastly, standard error of the slope. Don't freak out. It has a funky formula, but it's also right there. Standard error of the slope. Ha. I'm listening to an audiobook where the main character says ha a lot. No, I can't stop. So this is my margin of error, what I'm allowing myself to add and subtract from my point estimate. By the way, some of you do your confidence intervals really weird, not in the way that I have shown you how to do. So if you do the plus, it should go on the right side. I'm going to do 15.2 minus that. Okay, now it's interpreting time. What have we found out? We are 99% confident. We're estimating the true slope of the true least square regression line connecting sugar and flour freshness. The true 99% confident that the true slope of the least square regression line on sugar and freshness is between 9.0 and 21.4. And if you're feeling really fancy, units, this is your x, this is your y. For slope, it's rise over run. It's y over x, so it's going to be hours per tablespoon. All right. Can you use your calculator for the do step? You could. You could. Let's try it. What's that? Going over to tests. You're looking for the very, very last procedure here. So I would recommend moving up. Well, not the last one. G, linear regression t interval. List 1, list 2, 99. .04, 21.359. Slope, degree of freedom, standard, typical error. Y-intercept, r squared, r. Sure, but add the formula and the substitutions. You kind of really have to do that. You can always double check with the calculator, but it's not sufficient. Right? Supply that and the numbers that are going in there.